Okay, so earlier we saw relationships represented by graphs. Relationships can also be represented by a set of ordered pairs called a relation. And so we're going to take a look at the sample problem. In scoring systems of some track meets, for first place you get 5 points. And so what we did is we went ahead and take that first point and we represented it by the ordered points 1, 5. That's my ordered pair. And then we also have, for second place, you get 3 points. So here we represented that by 2, 3. That's my ordered pair to represent that. And then for third place, we get 2 points. So 3, 2. And for fourth place, we have 1 point. And so what actually ends up happening is we can represent this relation by that set of ordered pairs, but we can also represent it in different ways also. We could represent it by a table. So with a table, I can have, usually, that first number is called an X, and the second number is called a Y, and I can put that in a table. So first place gets 5 points. And then second place gets 3 points. And third place gets 2 points. And fourth place gets 1 point. And so that's my table. And then I can actually take that table and I can graph it. So if first place was 5 points. Second place, so second on my X, 3 on my Y, so second place was 3 points. Third place, so 3 on my X, was 2 points, so 2 on my Y, and I'm looking at where they intersect. And then fourth place, so 4 on my X, and 1 on my Y, and I'm looking where they intersect. And that's my graph. So we've shown it as ordered pairs, a table, a graph, and then we even have what we call a mapping diagram. And our mapping diagram takes these X values and puts them in a circle, and then takes my Y values and puts them in a circle, and then I show the relationship between them. So for my X value of 1, I ended up with a Y value of 5. And I draw an arrow to show when I put in 1, I end up getting out 5. And then for my X, when I put in 2, I got out a number of 3. And then for my X value when I had a 3, when I put in 3, I ended up with a Y value of 2. And then X value of 4 gave me a Y value of 1. And so in this section, we're looking at all the different ways we can represent what's actually happening in our relation, or also known as a relationship. Now, in our relationship, we have something called domain and range. And domain is going to be the set of the first coordinate. So the first number that you're seeing in that ordered pair, also known as our X values. Our X values are the domain. And then we have range. And our range is the second coordinate, or the second values, known as our Y values. So when I'm looking at domain, the domain of my track meet is 1, 2, 3, 4, or first place, second place, third place, fourth place. And then our range is the number of points, 5, 3, 2, 1. So when I'm looking at a graph, when I'm looking at a table, when I'm looking at that, we need to be able to establish what is our domain and what's our range. So when I'm looking here at this mapping, this first set of values should be my domain. So my domain consists of, and that's where we put these squiggly brackets, and then I list all the numbers in my domain, 6, 5, 2, and 1. Then my range is what I'm getting out. So those outputs. So the 6 leads me to -1, the 2 leads me to -4, 5 leads me to 0, 1 leads me to 0. So all these values here, that's our range. -4, -1, and 0. And that's it. That's our domain and range. So now we're going to practice expressing our relation as a table, graph, and mapping diagram. They give it to us as coordinate ordered pairs. So here I have 2, 3. So this is my x value, this is my y value. So I'm going to look at an x of 2, a y of 3, and where those intersect is my point. An x of 4, a y of 7, and where those intersect is my point. An x of 6, a y of 8, and where those intersect is my point. And that's it. That's my graph. So I took care of the graph. Now I have to write a table. So x, y. So my first point was 2, 3. So 2, 3. My next point was 4, 7. And my next point is 6, 8. And there's our table. Now we need a mapping diagram. So I'm going to draw my first oval, my second oval. In my first oval, I have 2, 4, and 6. The second one, I have 3, 7, and 8. And I just draw arrows that connect. X, when x is 2, that partners up when y is 3. When x is 4, that partners up with y is 7. When x is 6, that partners up when y is 8. And that's it. That's our mapping diagram. Now they ask us what's our domain and what's our range. So my domain should be all of those x values. So my x values are 2, 4, and 6. Also, what I see in that first mapping. My range is what I see in the y's, the 3, 7, and 8. Okay, so let's move to our next problem. We have our ordered pairs, so x and then y. So my x is -2 and my y is 4. So I'm going to look at where those intersect and put a dot there. My x is -1, my y is 3. So -1 and 3, where those intersect, that's where my dot goes. I'm going to keep doing that. 0 and 2, 1 and 3, 2 and 4. And there's my graph. And if I have these little, if I have these little things left over, sometimes it's good to erase it so you don't think that that's actually part of your graph. So my graph is really just those dots of those coordinates. So now I'm going to go ahead and move to that xy table, x, y. So my first point is -2, 4. Then -1, 3. 0, 2. 1, 3, 2, 4. And there's my table. Then I can move on to my mapping. -2, -1, 0, 1, and 2. And then in my y's, so this is where I've got to be careful, is because I get some numbers repeating. And with a mapping, they can't repeat. So I have a 4, a 3, and a 2, and then I have 3 again, and I don't list 3 again because 3 is already there. Then I get 4 again, but I don't list 4 because 4 is already there. And then I show where every number maps. So -2 maps to 4. -1 maps to 3. 0 maps to 2. And then 1 maps to 3. And then 2 maps to 4. So it's starting to get a little bit messy, but it gives you an idea of what's happening. And that's why we like mappings, is because mappings give you a really good idea of what your domain and range should look like. So my domain are the numbers -2, -1, 0, 1, and 2. But my range are the numbers 4, 3, and 2. And I don't list 3 and 4 again because just like in my mapping, they were already there. I don't have to list it again. And so when it comes to your Chapter 3 test, you have to be careful about this. If you have an extra 3 or 4 here, or if you have an extra 3 and 4 here, you will get points taken off. because the correct notation is not to repeat it in a mapping or in your domain or range. Now you can repeat in a table, that's fine, but not in a mapping or the domain and range. Okay, so now that we've talked about relations and different ways to look at relations, we have a special type of relation, and that's called a function. And so in a function, every x value can only have one y value. That means when I plug in a number into an equation like this, so I'm plugging in 2 right here, I'm only going to get one answer. I'm not going to get 2 answers. I'm not going to get 3 answers. I only get one answer every time. Never more than one answer. So how is this going to look? This is going to look like if we have a set or a table, none of our x values can be repeated. So if we're looking at a set, we're looking at those x values, and if we see the number 4 listed twice, it's not a function. If I look at a table and I see the number 4 for x listed twice, it's not going to be a function. Because if it's listed twice, that means it has 2 different y values, which is not allowed. Okay, when we're looking at a mapping, each x value only has one arrow coming from it. Because that means one arrow means one answer. If you have 2 arrows, there are 2 answers, and it's not a function. And then our last one is in a graph. In a graph, we use what we call a vertical line test. And so what we're going to do is we're going to draw a vertical line, which is straight up and down. And if it touches our graph at 2 points, then it's not a function. So for example, if I have a graph that looks like this, when I draw a vertical line, it touches that black graph at 2 points. So it can't be a function. And so that's the idea of a vertical line test. So let's try some sample problems. Our first ones give us mappings, and we want to know domain. So our domain for this one is everything in the first oval or rectangle. So -4, -8, 4, and 5. And then we have a range. Everything in the second rectangle, which is 2 and 1. And now they want to know, is it a function? So because it's a mapping, we're looking up here at our mapping rule. In a mapping, each value has one arrow. So as I'm looking, 1 arrow, 1 arrow, 1 arrow, 1 arrow. So yes, it's a function. Okay, so for our next example, our domain is the first rectangle, 4, 3, 2. And then our range is our second rectangle, -5, -4, -3. And then we want to know, is it a function? So I'm looking at my x values and I'm saying, okay, 1 arrow, 1 arrow. And then all of a sudden, 2 arrows. Because there's 2 arrows, the answer is no. Because 2 has 2 outputs, or 2 y values. And those outputs are -5 and -4. So this is what tells us no, it's not a function. When I put in the number -2, I get 2 answers, and that's not allowed. Only 1 answer is allowed with a function. Okay, so we're going to continue seeing these. We're looking at these sets. We're looking at these ordered pairs. So when I look at my domain, I'm looking at the first number only. So I'm looking at 8, -4, -6, and 1. That's my domain. For my range, I'm looking at the y value, or the second number, 2, 1, 2, which I already listed, so I don't list it again, and then 9. Now to determine if it's a function with this set of ordered pairs, I'm looking for any x value that's listed twice. So when I'm looking, does any number pop up more than once? And I'm looking at only these red ones. So I've got 8, -4, -6, and 1. No number is listed twice on the x's. So this is a function. Okay, on our next one, we're going to do the same idea. So we're looking at our domain, which is the first number. So 2, 1, 0. And then I get 1 again, so I don't list it. And then I get 2 again, so I don't list it. That's my domain. Then I'm going to go to my range. So now I'm going to look at the y values. So for my range, I have 4, 3, 2, -3, and -4. No numbers are repeating there, so I can list them all out. Now I have to decide if it's a function. So for a function, I'm looking at the x values. So are any of my x values repeated? Boom. 1's repeated. There's a second time 1 occurs. Boom. 2's repeated. So no, this is not a function. Because 1 has 2 outputs. Because 1's listed twice. And then 2 has 2 outputs because 2 is listed twice. Okay, so now we're going to move on to our graphs, and we're going to do that whole vertical line test. So I'm looking at, can I draw a line so it touches at more than one point? So when I draw a line here, it touches red at 1, 2. So this is not a function. Over here, I'm going to go ahead and draw that line. Vertical line. Oh, it touches at 1 point. So I'm going to try again. Can I draw another one? Nope, that touches at 1 point. So I keep trying, and I don't have to draw it. I just have to think about it. Anywhere, can I draw a line where it's going to touch twice? And I can't. There's just no possible way. So that means it is a function. So now what I want to talk about is I want to talk about domain and range. And so when it comes to domain and range, domain's looking at all my possible x values. So I'm going to look at my shape here, and I'm going to look at what's the farthest right hand my shape goes. So my shape to the farthest right goes right here. My shape on the farthest left goes right here. And so that means that my x values can be any number between here, 2, and here, -3. So this is where I write an inequality, because this is a continuous function. Everything's kind of continuing and connected. So x can be anywhere between 2 and -3. Okay, now if I want to do range, I'm looking at top and bottom. So I want to look at the very top of my graph. The very highest my graph goes is right here, right at that little corner. And the very lowest my graph goes is right here. So when I'm looking at my range, I'm looking at these y values. So that's why I'm using that y-axis, which goes up and down. So I'm looking at top and bottom. So my highest y value is 4. And my lowest y value is -2. And so that's how I figure out that range. Okay, so now I'm going to look at the next graph, and we're going to do that same idea. For domain, I'm going to look at the farthest left and the farthest right that my graph goes. And I draw a line all the way down to the x-axis so I can kind of understand what are those x values. So for my domain, I'm looking at x being between this number, 5, and this number right here, 1. Now for range, I'm going to look at the top and bottom of my graph. So the very top part of that red graph is right here. The very bottom part of my red graph is right there. So when I'm looking at that range, I'm looking at, oops, I didn't mean to do that. I'm looking at y being between, my lowest number is 3 and my highest number is 4. So y is anywhere between 3 and 4. So we're going to do a little activity with this in class to kind of get a better idea of domain and range. And so we'll work on that then.